Good morning, students. Today we will start our mathematics syllabus starting with chapter 1, that is knowing numbers. You know natural number. Natural number means any object in the nature which we can count. If we can't count, then it is zero. Object is not existing in the nature means no object means zero. So all the objects which we can count are counted by using natural number, that is 1 2 3 4 5 6 and so on up to infinity. So natural number starts from 1. If we add 0, then it becomes whole numbers. So you will remember it that the spelling of whole is WHOLE. So there is O means 0. So if we add O, that is 0, to natural numbers, it is called whole numbers. The natural numbers, if we consider the negative natural numbers, then it become integers. So integers are negative natural number, 0 and positive natural numbers. Then what about the decimal numbers or numbers in a fraction? So decimal numbers or numbers in a fraction are usually represented as A upon B. So even a natural number, for example 2, if 2 is expressed in 2 upon 1, we can express 2 as 2 upon 1. We can express 3 as 3 upon 1. It is called a rational number. Any number which can be expressed in a upon B form is called a natural number. Now you will ask me, what about 1.5? So 1.5 can be represented as 3 upon 2. So 1.5, we can write 1.5 as 3 upon 2. So 1.5 is expressed in a 3 upon 2. It is an integer, or integer integer 3 upon 2 has a decimal representation as 1 upon 5. Correct. So we know the rational number. Now I will first explain you irrational number and then rational number. What are the rational numbers? The number whose decimal representation is non-terminating and non-recurring. Non-terminating and non-recurring means, suppose we divide 1 divided by 3. 1 divided by 3. 1 divided by 3, what it gives you? 1 divided by 3 gives you 0.3, 0.3, then 3, then 3, then 3. So it is repetitive, okay, or recurring. The number whose decimal representation is non-terminating. So it is non-terminating, yes. It's non-terminating, yes. But is it non-recurring? No. It is recurring. It is repeating. So 1 upon 3 is not a irrational number. So all those numbers, when expressed in a decimal representation, then they can be terminating or non-terminating. For example, if you divide 1 by 2, what is the answer? 1 by 2, the answer is 1 by 2, answer is 0.5. This is final answer. So if you divide 1 by 2, the answer is 0.5. It is terminating, correct. But if you divide 1 by 3, the answer is 0. Answer is 0.33. Answer is 0.333, and it will carry on. So this is not repetitive. This is repetitive. 1 upon 2 is repeated. 1 upon 2 is terminating, and 1 upon 3 is non-terminating. 1 upon 2 is terminating. 1 upon 3 is non-terminating. So a irrational number can be terminating as well as non-terminating. But one more characteristic of rational number is that if it is non-terminating, then it is repetitive or recurring. This repetitive or recurring character is not with irrational. Irrational number is non-recurring. Irrational number is non-recurring. And it is non-terminating. So difference between the rational and irrational is rational number is terminating and non-terminating. Both characters are there, whereas irrational number has only one character, that is non-terminating. But rational numbers are repeating and recurring. Irrational numbers are non-recurring. Okay, then there are limited examples of irrational numbers. Irrational numbers are limited. Which are those? The square root of non-perfect. The square root of non-perfect squares. So the square root of non-perfect squares. So root of 2 is 1.4121 and so on. Okay, it is non-terminating, non-recurring. Root of 3 is same. Root of 5, root of 6, root of 7, root of 8, root of 9. Root of 9? No, 9 is a perfect square. So root of 9 is rational number. Root of 9 is 3. 3 is a rational number. 3 can be expressed in the form of 3 upon 1. Then pi. Last year you have learned the circle, the area of circle, 2 pi r square. So pi is a irrational number. Exponential e is a irrational number. Exponential e is a irrational number. Gordon ratio phi is irrational number. So we have learned natural number, whole number, integers. Natural number, whole number and integers can be expressed in a rational form, that is a upon b, correct? And there are irrational numbers like square roots of non-perfect squares, pi and other things. Now this total of rational and irrational numbers forms the real number. So it forms the real number. The real number is group of rational number, and it is group of rational number as well as irrational number. Correct. So I have made it in a pictorial form. So natural numbers. So all whole numbers are natural numbers. So natural number is a subset of whole numbers. All natural numbers are whole numbers. All natural and whole numbers are integers. All natural and whole numbers are integers. All natural, whole and integers can be expressed in a upon b form. So there are rational numbers and there are few irrational numbers. The combination of rational plus irrational gives real numbers. Now let us remember some of the facts. The smallest natural number is 1. The smallest natural number is 1. And the largest, the greatest negative Sorry, the smallest natural number is 1, and greatest, there is no greatest number. Greatest is infinite. So smallest natural number is 1, greatest infinite. Smallest whole number is 0 because whole number starts from 0. Greatest whole number, obvious, it is infinite. So no greatest whole number. 0 is neither positive nor negative. It is neither positive nor negative. The greatest negative number is the greatest negative integer. The greatest negative integer is -1. Then smallest positive integer is 1. The greatest negative integer is -1. So which is the smallest negative integer? There is no smallest negative integer. Then the smallest positive integer 1, which is the greatest positive integer, it is infinite. So there is no. So there is no smallest negative integer. Same thing, there is no positive integer, no greatest positive integer. Now let us start solving few of the examples. The number whose decimal representation is recurring and non-terminating. If it is non-terminating, it can be a rational number and or irrational number. Rational number or irrational number are non-terminating. But what they have mentioned, recurring. If it is a recurring means it is a rational number. Rational numbers are recurring, repeating. Okay, but but in options they have given irrational, real and integer. So all the rational numbers are real numbers. So there are two answers. Next question. 2, 7, 8, 5, 9, 1 are the given digits. Choose any four of them. Choosing any four of them, we can form many 4-digit numbers. Consider the greatest of all of these 4-digit numbers. What is the double of the digit in the unit place of that? So let us write the greatest 4-digit number. So which is the greatest number? So 9. 9 we have to take as first. Then which is the greatest? Then the smaller than 9, it is 8. Then smaller than 8, it is 7. Then 5. So greatest 4-digit number that can be formed is 7, 8, 9, 8, 7, 5. The unit place of this number is 5. So 5 into double of 5 is 10. So answer is 2. The answer is 2, 10. 10. Okay. Next question. What is the difference between the digit of 1000 place and 10th place of a number formed by adding the greatest 4-digit number and the smallest 1-digit number? Okay. So first we have to find the greatest 4-digit natural number. Greatest 4-digit natural number is 9999. The smallest 1-digit natural number is 1. Correct? Total of that is, sum of both is 10,000. What is the question? Find the difference between the digit at the thousands place. So at a thousands place, which is the digit? It is 0. And at the tens place, which is the digit? 0. So 0 minus 0 is 0. Option 1 is the right answer. Correct? Next question. Which of the integer form 0, 1, -1 and 10 is the smallest integer? Integer become smallest if we move on the left side. So -1 is the greatest negative integer. If you go beyond left, then -10. -10 is the descending order. -10 is the smallest integer. Answer option 4. Option 4.
Yeah.
From the digit 20598, the greatest and the smallest 5-digit number are formed by using each digit only once. Find the digital sum of the difference between these two numbers. So let us first form the greatest number. Greatest number is obvious, we have to start with 9. The sequence is 9, then 8, then 5, then 2, and then 0. So greatest number is 9, 8, 5, 2, 0. The smallest number, we cannot start with 0, because if we start with 0, then it will not be a 5-digit number. So we have to take next greatest number after 0. So we start with 2. 20586 is the smallest number. The difference between the two is 77931. The sum of the digits in the difference, the sum of the digit in the difference. So find the digital sum. Find the digital sum of the difference. The difference is 77931. So digital sum means we have to add number. So 7 plus 7 plus 9, 7 plus 7 14, 14 plus 9 23, 23 plus 3 26, and 1 27. So option 1 27 is the answer. Option 1 is correct. From the following, which is the decimal representation of 135,142? Okay, so what we have to do, we have to first write 135. Correct. 135. We have to first try to reduce it. 135 divided by 42. 135 divided by 42. Okay. Now if you look at this number, 42 is even, whereas 135 is odd. So we cannot divide it by 2. Can we divide it by 3? Let us check. 4 plus 2 is 6. So 6 is divided by 3. We can divide. 1 plus 3, 4. 4 plus 5, 9. So 9 is divided by 3. So we can divide by 3 both numbers. So we divided by 3. 3 4s are 12. 3 4s are 12. Carry over 1. 15. 3 5s are 45. So answer is 3 5s are 15. So answer is 45. 45 divided by, now you divide by 3. 3 1s are 3. Carry over 1. 3 4s are 12. So answer is 14. Now you know the 14 table. Now you divide 45 by 14 directly. 14 3s are 42. So 14 3s are 42. So 3 is the answer. Correct. 42. So if you divide by 45 by 14, remainder is 3. Correct. Now we add 1 0 here. So 14, if we divide 30 by 14, answer is 14 to the 28. Answer is 28. If you divide 28, remainder is 2. You add 1 0 here. If you divide it by 14, answer is 1. Correct? Answer is 1. If you divide by 20, then answer is, remainder is 6. If you add 0, 14 4 the 14 4 the 56. 14 4 the 56. Remainder is 4. Correct? Add 0. 14 2 the 28. So 2. 28. 28. Remainder is 12. Remainder is 12. Okay. Then you add 1 0. 14 8 the 14 8 the 112. and carry on. So this is the number. So 312428857 and repeating 2148572 plus 14258. If you keep on adding, we get a recurring. So from the following, which is the decimal representation of 13542? This is the decimal representation, because after that you get a repeating number. So option 4 is the correct answer. What is the sum of the greatest negative number and the smallest positive number? You know which is the greatest negative number? Greatest negative number is -1. Smallest positive number is 1. Answer is 0. If you add, answer is 0. So option 4 is correct. Group of real numbers means, real number means rational plus irrational. Group of rational plus irrational. This is the right answer. From the following number, which is the group of irrational number? Now, we have to find the irrational number. Before that, what is the meaning of irrational number? Irrational number is a root of non-perfect square. So we have to first check who are the perfect square. 49 is a perfect square, it is 7 square, 7 square, 49. 64 is a perfect square, 8 square of the 8 is 64. Okay. Then means these two answers are wrong. These two answers are wrong. There is a rational number. So this group is wrong. Now check this. What you find? 8888 is repetitive. So irrational number should have non-repetitive. This is repetitive. So this answer is wrong. So which is the right answer? This is the right answer. Form the greatest and smallest 5-digit number from the digit 0, 1, 2, 3, 4, 5, 6, 7 without repeating a number. Adding these numbers, what is the place value of the digit in the thousand place of that sum? So greatest 5-digit number formed by giving number is, we have to start from bigger one, 7, 8, 7, 6, 5, 4, 3. This is the biggest number. Smallest 5-digit number is obvious. We cannot start with 0. We have to start with 1, 1, 0, 2. Sum of this number is 8677. The digit at the thousands place is 6. Digit at the thousand place is 6. Place value of 6 is 6000. So option 3 is correct. Place value is 6000. Thousand place is 1000. 6000. Without repeating any digit from 4, 3, 5, 7, 8, if we form a smallest 5-digit number, and then what is the difference between the place value and the face value of its thousand place? So first we have to find the 5-digit smallest number. 5-digit smallest number is this. Okay. Then what is the difference between the place value and the face value of its 100 place? Who is at 100 place? 4. So what is the face value of the digit at 100 place? 4. And what is its place value? 4000. Digit in 100 place is 4 and the face value is 400. So what is the difference? 396. Answer is 396. Correct. 357941 are the given digits. Choosing any 5 of them, we can form many 5-digit numbers. Consider the smallest of them. What is the difference between the place value and the face value of the digit at the thousand place? So we have to find the place value and the face value. So 5-digit number, obvious. Smallest 5-digit number 1, 2, 3, 4, 5. Correct. Smallest 5-digit number 1, 2, 3, 4, 5. Digit at its thousand place. Difference between the place value and face value of a number at the thousand place. So who is at the thousand place? 2 is at the thousand place. So what is the face value? 2. And what is the place value? 2000. Place value is 2000. Face value is 2. Difference between 2000 minus 2, 1998. So answer is 3. What is the difference between the place value of a digit in the thousand place and tenth place of a number formed by adding the greatest 5-digit number and 1-digit number? Which is the greatest 5-digit number? 99999. 99,999 is 5-digit greatest number. Which is the smallest 1-digit number? 1. If we add 99,991 plus 1, answer is 10,000. So who is at hundreds place? Hundreds place we have 0. Who is at tens place? Tens place is also we have 0. Correct. So difference between the place value. Difference between the place value. So place value. So place value at 100 place is 0. The place value of 100 place is, what is the place value? The number is 0. Its face value, if it is 1, then the place value is 100. But if the number itself is 0, then what is the place value? 0. If the number, for example, if the 100 number is, for example, here, what is the face value? 2. And what is the place value? Face value is 2. What is the place value? Place value is 2000. Correct. The place value is 2000. Place value is 2000. Here the digit at 100 place is 0. So place value is 0 0 0 0. The 10th place is digit in place is 0. So what is the place value of this number? 0 0. So difference between them is 0 0 0 0 means 0 minus 10 place, which is the number 0, and what is its place value? 0. So answer is 0. Answer is 0. Okay, let us solve some examples. 0 4 8 9 6 5 7 3 are the given number. Choose any 5 of them. We can form a greatest and the smallest 5-digit number. So let us form a greatest 5-digit number. So greatest 5-digit number is 9. Obvious, 9 is the first number. Then we have 8. Obvious, we have 8. Then we have 7. 7. Then we have 6. Yes, we have 6. Then we have greatest 5-digit number. Yes, then we have greatest 5-digit number is 5. Okay. Choose any 5 of them. Choosing any 5 of them. So we have to choose 5. We can form a greatest and the smallest 5-digit number. Now we have to find the smallest 5-digit number. So which is the smallest digit? Smallest digit is 3. So we should start from 3 and then 0 and then 4 and then 5 and then 6. Add this number in the sum. So we have to add this. Add 6 plus 5, 11. Carry over 1. 6 plus 1, 7. 7 plus 5, 12. Correct? Carry over 1. 7 plus 1, 8. 8 plus 4, 12. Carry over 1. 8 plus 1, 9. Perfect? 9. 9 plus 3, 12. What is the place value of digit in 100 place? Who is in 100 place? 2. What is its place value? 200. Answer is 200. Correct? 3 7 2 1 4 8 are given digits. Choosing any 4 of them, we can write many 4-digit numbers. Consider the greatest of them. Write the double of the digit in its 10th place. Write double of the digit in the 10th place. So we have to form a 4-digit greatest number, which is the big number 8. So first number is 8. Second number is 7. Third number is 4. And last number is 3. So this is the 4-digit greatest number. Double the digit in its 10th place. Who is in 10th place? 4. So 4 into 2 gives 8 is the answer. This is the answer. So students, I hope you have understood the method of solving these examples. Take the example 5 and 6 as a homework. 7, 8, 9, 10, 11, 12, 13, 14 and 15 we will solve tomorrow. Thank you.